Hello and welcome to Solving Proportions. So today we're going to look at two things. We're going to first look at whether or not numbers are in proportion with one another, meaning that the ratios are equal, kind of like equivalent fractions. And we'll look at that in a second. And then we're going to look at a proportion that we know is proportional, and we're going to find an unknown value. And there's a couple ways to do that. So let's start off by just identifying what a proportion is. And a proportion is an equation that states that two ratios are equal. Okay, so let's say we have something like this. We have 1/2 is equal to 2/4. Well, we know that's true because 2/4 reduces to 1/2, right? That one's kind of an easy one to look at and say, yeah, those are in proportion. But what if we had something like this, like 5/7 equals 15 over 21, okay? Now, here's what we're going to do. We're going to determine if these are in proportion, and there's a couple ways to do it. You could reduce each fraction, and if they're the same, then they're equal, or you can do what's called cross products. So check this out. If I multiply the 7 by the 15, so in a diagonal pattern, 7 times 10 is 70, 7 times 5 is 35, and 70 plus 35 is 105. Okay, and so I'll just show what I did here. I did 7 times 15 equals, and now I'm going to go in the other direction. And 5 times 21 should equal the same thing as 7 times 15 because of that equal sign in between them. So 105 equals 105. If we do the same thing here, we get 4 equals 4. Yeah, so that's called cross products. We multiplied in an X pattern, and product means multiply. So what we're going to do is we're going to check to see if numbers are in proportion. And to do that, we are going to check their cross products. Okay. So they give us an example here. If A over B equals C over D, then B times C has to equal A times D. And remember, anytime you put two letters together, that means multiplication. Same thing as like 2x, that means 2 times x. Okay, so, and draw those little X things that we circled. And please put those examples at the top if you haven't already. So hit pause if you haven't done that. Okay, so now what we're going to do is we're going to determine whether the pair of ratios forms a proportion. Okay, so you can go with cross products the whole time if that's what you want. You can also use something that you learned about last year called the giant one. If I look at number 1, I can see that I can turn 6 into 24 by multiplying by 4. And whatever you do to the bottom, you got to do the top. And 5 times 4 is 20. So the giant one is an easier way to do this than trying to multiply 6 times 20 and 5 times 24. So if you can see it, times 4 times 4, and this number right here is the same, then that means they're in proportion. So I would write yes. Okay. Now, here, look at number 2. If I do 3 times 5 to make 15, but 2 times 4 makes 8, not the same thing. So I would say not in proportion. Okay, so let's try the giant one and see how far that gets us. Okay, so we're going to do 7 times 6 makes 42. 9 times 6 makes 54, so those are in proportion. Okay, here's where it gets tricky. Look at number 4. I do not know how to turn 18 into 45. It's probably multiplied by some decimal. So the giant one no longer works. Here it worked, and we found out it wasn't the same. Here it worked, and it was the same. But number 4, I don't know. So this is where I would use cross products. So I would do 18 times 28. So please write down what you're multiplying so I know you understand this concept, equals 8 by 45. And I'm totally fine with you using a calculator, but you do have to show what you wrote down so I can see it. Okay. Now I would multiply those two together and I get 360 on this side. It shouldn't be 360. That's weird. Let me get my calculator because 8 times 8 is 64. So it can't end in a 0. Oh, my calculator's not working. Let me get my phone. Okay, we got this. 18 times 20. I probably could have just done it faster. 504 is what I got. Okay, so that equals 504. And on the other side is my 360. And notice they're not the same, so I put a little line there and I say, no, these are not in proportion. Okay, so let's do one more. Let's look at number 6. I do not know how to multiply 1.6 to get 8. So I'm just going to do cross products. I do know that this, though, is a 5. 7 times 5 makes 35. So 1 times 6 might, 1.6 times 5 will probably give me 8. But let's just do cross products to see, because I want you to see that idea. So I get 1.6 times 35 equals 7 times 8. Okay, 1.6 times 35 is 56. And we know that 7 times 8 is also 56. So yay, they form a proportion. Okay, so what I'd like you to do is I'd like you to try the last 3 on your own in this section. So 5, 7, and 8. Look to see if you can use the giant one. And if not, do the cross products. And again, show what you typed into the calculator and show whether it was true or not, and then write your answers. There should be 3 things for each problem. Okay, see you in a second. All right, so for number 5, I got yes, because 840 equals 840. For number 7, I got no. I got 20 equals 27, not true. And then for number 8, I got yes, because 615.6 equals 615.6. Okay, so now we know whether things are in proportion or not. For the rest of the guided notes, everything is going to be already in proportion. And we're going to use that idea to find what we call the 4th number. So let's take a look. So look at number 9. I've got 16 over 12 equals something over 3, okay? Now, we can use the same strategies as before. So we can use the giant 1 method to solve these. Or we can use cross products. And again, if you're like, well, I don't really want to think about giant 1 and cross products, just do cross products the whole time. It doesn't matter. It is kind of nice to do the giant 1 though, because it saves you steps and you can get there quicker. So if you see it, I would use it. Okay, so here's what we want to do. In number 9, if you can figure out how to go from 12 to 3 using multiplication or division and apply that to the top, that's how you solve it. So 12 divided by 4 makes 3. So whatever you do to the bottom, you got to do to the top. And 16 divided by 4 makes 4. So x is 4. Now check this out. That seems really easy, right? Well, how do we know if it's right or not? Well, we're saying that 16 over 12 should equal 4 over 3. Well, what does 16 over 12 reduce to? 4 goes into both of them, right? 4 goes into the top 4 times and into the bottom 3 times. So we end up getting 4/3 equals 4/3. That's actually another way to solve it. Okay, so let's look at a few more. Let's look at number 10. Okay, 7 times 3 gives me 21. So if I do 8 times 3, I should get 24. So k equals 24. And then we can just check it really fast to make sure that 21 divided by 28 does turn into 7/8, and it does. So there's my answer. So see how the giant 1 method is pretty straightforward. That's why I like to use it. Okay, problem, look at number 11. I do not know how to turn 5 into 26. So the giant 1 method has its limits. We've reached them. So now we're going to do cross products. So we're going to do 5 times w, and we just write 5w equals, and then we're going to do 6 times 26. So Kylie, sorry, my cat really likes math. So 26 times 6 is 6. Put the 3 up, 156. Okay, now I have a 1-step equation that I need to solve. So I'm multiplying by 5. I need to undo the multiplication by doing division. So I divide by 5, divide by 5. And remember, calculators are fine. Just write what you put or what you're typing in, just like I'm doing. W equals 31.2. Okay, this one is a little bit harder to check because you can't just reduce the fractions. So the only other thing you could do is just look over your work and make sure that you got all the numbers right. Okay, cool. Let's look at number 12. Looks like, oh, I'm looking at 9 and 63. Yeah. So if I take 63 and divide it by 7, I get 9. Whatever I do to the bottom, I got to do to the top. And 14 divided by 7 is 2. So A is 2. And notice each time I'm putting the variable that they gave me in the problem, I'm putting an equal sign, and I'm putting the value that we found. Okay, you can't just write 2 because you're solving. And when you solve an equation, you have to have an equal sign in your answer because there was an equal sign in the question. Okay, so we can check this by reducing this to 2/9, and 2/9 equals 2/9. So I'm good. Okay, cool. So, sorry, my cat. Kylan, get over there. Okay, love you. Okay. All right. So let's go to the next page. I want to do a couple more examples with you, and then I'll have you try some on your own. Okay, so let's skip down to number 17. Okay. All the rest of the problems are really similar to the examples I just gave, except for number 17 and 18. Notice in number 17, there is a 4x, not just a regular x. So we solve it the same way. It's really tricky to do giant 1 when there's a coefficient. A coefficient is the number in front of the variable. So I'm going to do cross products on this one. And I'm going to do 5 times 84. So I'm going to write 5 times 84 equals, and I'm going to do 4x times 15. 4x times 15. Okay. You could have put the 15 in the front too. It doesn't matter. Okay, so we're going to do 5 times 84, and we get 420 equals, and now I have 3 things being multiplied on the right side. I have 4 times x times 15. So I'm going to multiply the 2 numbers together and bring them to the front. And 4 times 15 makes 60, so I get 60x. Okay, now one-step equation to solve. So divide, stop it. Sorry, she's biting me. Yeah, she always bites me. 60x divided by 60 and 420 divided by 60. Zeros cancel out. 42 divided by 6 is 7. So x equals 7. Okay. Cool. Now I can check this because if I plugged it back in, I would get 4 times 7 right here, which is 28. So the question is 28 over 5 the same thing as 84 over 15? And I could use the giant 1 to check this and say, hey, times 3 times 3. And then is 28 times 3 equal to 84? I hope so. It is. Yes, we got it right. Okay, so let's try one more of those. Okay, let's do number 18. So 15 times 8.4. Remember, show what you're doing equals 2 times 7c. Okay. So 15 times 8.4 gives me 126. And 2 times 7c, remember to multiply the 2 times the 7 gives me 14c. Okay, now I'm ready to solve. Divide both sides by 14, divide by 14, and c is 9. Okay, this one's a little bit harder to check, but I could, because I could plug the 9 in for c and decide is 8.4 over 9 times 7 is 63. Is that the same thing as 2 over 15? I could turn them both into decimals and compare the decimals. So the checking isn't required, but it's always recommended. Okay, I'll just throw that out there. All right, cool. So here's what I'd like you guys to try. I'd like you to try 2 on your own, and I want you to do 13 and 14. So always look to see if you can do the giant 1. If you can, go with it. If you can't, do cross products. Okay, I'll see you in a second, and don't forget to write everything down. Okay, we're back. So for number 13, I tried to do the giant 1 because 6 and 30 work nicely together, but then 19 really isn't divisible by 5. So you could have figured out what 19 divided by 5 is and then make that the answer. That's one way to do it. So I just decided to do cross products because I really like that for some reason. And I got n equals 3.8. For number 14, I had to use cross products, and I got m equals 3.3. Okay, cool. So that's the end of the lesson if you're going to do the green homework. However, if you want to do exceeding problems and then apply those to the test, you would want to do the next few examples. Okay, so we're just going to do 2. And I really like these, and you're going to do more of these in algebra, but this is a fun intro right now. Okay, so let's do number 20. Notice that not only is there a variable, but there's like an addition sign in the problem. So like this one here has x minus 2, a plus 7, r minus 1, r plus 6. Yeah, there's a lot more going on. So the best way to solve these is using cross products, okay? And when we multiply this way, we're going to get 10 by 2. So I'm just going to write 20. However, when we multiply this way, it's 5 times both of those things. And the way to show both is using the distributive property. So I'm going to do 5 times the a and the positive 7 like that. So you write it out as a distributive property problem. Then you distribute. So 5 times a is 5a. 5 times 7 is 35. And then I got equals 20 on the other side. Now it's a two-step equation that you solve. So subtract 35 from both sides. And I get negative 15 equals 5a. Divide both sides by 5. And a is negative 3. Awesome. Now there's a way to check it, because if I plugged it back in, negative 3 plus 7 is 4. So is 10 over 4 the same as 5 over 2? It is. They both reduce to 5/2. There you go. Okay, number 22 is one more step up, okay? And because you're going to distribute twice. So I'm going to get 7 times c plus 10 equals 4 times 5c minus 2. You set it up as two distributive property problems. Now we're going to distribute 7c plus 70 equals 20c minus 8. Now we got to get our variables on the same side. So I'm going to subtract 7 from both sides. So 70 equals 13c minus 8. Now I'm going to add 8 to both sides. 78 equals 13c. Now I'm going to divide both sides by 13. C equals 6. If I plug that back in, I get on the right side 16 over 28. Because 5 times 6 is 30 minus 2. Does 16 over 28 reduce to 4/7? It does, because they're both divisible by 4. So there's the answer. Okay, so those are the blue types of problems you're going to see on the worksheet. So take a look at the worksheet. Try these two on your own, actually, and then you can decide if you want to do blue. And then on the homework, it will tell you which ones to do for blue. Okay, so take a minute, try 19 and 21, okay? And let's just see if you're ready for those blues. All right, see ya. Okay, here's what I got. The hardest part is the distributing. That's where people make the mistake. So I did show that first step. And for number 19, I got 10. And for number 21, I got 8. Okay, so decide if you want to do grade level or blue. Good luck and have fun with these. I really like these problems for some reason. Okay, bye.